All right, this is the Unit 5 review. I'm going to go over these 20 questions. Please pause the video between each question so you can try them on your own. Your assessment, which is also posted, is going to be based off of these questions as well. If you have any additional questions, please feel free to reach out. Here's question number 1. A town's population was initially 500,000 people and is losing people at a rate of 3.6% each year. An exponential function to model the decay of the town's population is of the form a of t equals a parentheses b to the t power, where a of t is the town's population after t years. What is the value of the b in the function? Give an exact answer. So the b is the base. The way these work is you have your a of t, that's like your y value. Your 500,000, that's like your a value. So remember, a times b to the x power, okay? The a value is going to be your starting amount. Your b, since this is exponential growth or decay, is going to be 1. Since it's going to be losing, that's going to be decay. So it's going to be 1 minus the rate. And then we raise it to the t power. And so this is your a value. This is your b value. Our goal is to figure out what is that number after I subtract the rate. So since my rate is 3.6%, I want to first convert that to a decimal. I'm going to move that decimal over 2 places to the left. So it's going to be 0.036. And then I'm going to take that and subtract it from 1 since it's losing. And that's going to be your b value. So 1 minus 0.036. You can put that in your calculator. And that's 0.964. So the equation would be a of t equals 500,000 0.964 to the t power. So what you would put in this problem is 0.964. That's your base, that's your b value. Oops, let's put a decimal. All right, question 2. A bank account has an initial investment of 1,500 and is growing at a rate of 3.4% yearly. What's the amount on the account after 20 years, round to the nearest cent? So we're again going to follow that same formula. Capital A, I just use A, I don't need the A of t, equals lowercase a times b to the t power. And since this is going to be growth, we know it's going to be growth because it's growing. It says the word growing. Since the rate is 3.4% as a decimal, 3.4 divided by 100 is 0.034. Since this is growth, it's going to be a1 plus r to the t power. Well, the r value is 0.034. So it's going to be 1,500, 1 plus 0.034, and the t value is 20 years. So we'll raise that to the 20th power. So it's capital A, that's your final amount, equals 1,500. 1 plus 0.034 would be 1.034. And we want to raise that to the 20th power. So we're going to put that in our calculator. And your amount is 2927.53, 458,377. Now the question wants to know, what is the amount to the nearest cent? So nearest cent would be two numbers after the decimal point, because dollars and cents, dollars is before the decimal, cents is after the decimal. And since there's 100 cents in a dollar, so these are hundredth places. So 2927.53, 2927.53. So it's like $2,927.53. Question 3. F of x equals 3 to the x power. G of x is 3 to the x plus 6 minus 7. What are the transformations that map f of x onto g of x? Well, we can use our rules of transformations, but basically, Caitlin, turn it down, please. The rules of transformations are in the exponent. If I want to go from 3 to the x to 3 to the x plus 6, that's going to move this left 6 because that's going to be the opposite of what the x and y axis would be. So like on the x-axis, you know, that's the positive direction, that's the negative. This flips it, so this is going to be left 6. And then at the end, if I subtract the number, that's going to take it down 7. There's 3 to the x power. When you put stuff in the exponent, make sure you use parentheses. You see it took it left 6, and then if I do minus 7, that's going to shift it down. So left 6, down 7. That's going to be answer choice. 6 units left, 6 units left, 7 units down. That's going to be C. Okay, question number 4. A piecewise function is shown below. 3x squared minus 2x plus 4 if x is less than or equal to negative 2. 2x plus 8 if negative 2 is less than x, which is less than or equal to 5. And 5x to the third minus 7x if x is greater than 5. And also we have an exponential function shown below. Okay, so in this problem, what we want to do, since the question says, what is the value of f of 11 minus g of 8? We first want to go up to the piecewise function. That's your f function. And we want to figure out where to plug in 11. So since 11 is not less than negative 2, and it's not between negative 2 and 5, 11 is greater than 5. So since 11 is greater than 5, f of 11 is going to be what you get when you plug in 11 into the bottom function. And that's probably going to be a fairly large number. So let's go to our calculator and figure it out. 5 times 11 to the third power. We'll go to Desmos. 5 parentheses 11 to the third power minus 7 parentheses 11. And wow, that's going to be 6578. So we'll write that down. Now let's go to the g function. So g of 8 is going to use this table here. And really, I just want to look at the pattern and figure out what's being done to the previous one. So since I'm going from at 0, g of 0 is 1, g of 1 is 3, g of 2 is 9. What is the common multiple that allows us to go from 1 to 3 to 9 to 27 to 81? What is being multiplied each time? And if you guess 3, you're right. So g of 0 is 1. I'm going to move this all the way up to 8. So again, the common multiple is times 3. So we just want to keep multiplying our previous number by 3. And 81 times 3 is going to be 243. Beyond that, I'm probably going to use a calculator as well. So 243 times 3 let's see. $729. 729 times 3 is 2187. And 2187 times 3 is 6561. So let's take a moment to jot those down. So g of 8 is 6561. And so now the question is really, what is f of 11 minus g of 8? So f of 11 minus g of 8 is going to be 6578 minus 6561. And that looks like it's going to be 17. So your answer for that is 17. And question 5. Okay, question 5 is another problem where we're going to use the rules of transformations. The parent function f of x equals 5 to the x power is transformed such that it is reflected across the x-axis, stretched, and translated up 6 units. It doesn't say how much it's stretched by, but if it's going to be reflected across the x-axis, the first thing you want to have is a negative sign. So that negative out front is going to reflect. And if it's going to go, if it's going to be stretched, then we want the leading number to be greater than 1. So it could not be like 1/4, and it could not be 1. We want it to be like something like, well, it'd have to be one of these two. It had to be -4, because 4 is going to stretch it. So that 4 would work. And if I wanted to go up 6 units, I'm going to want to add 6 units on the end, because remember, up and down is the end number. So if it's going up, it's going to be +6, and if it's going down, it's going to be -6. So I want this number to be greater than 1. I want that to be negative for reflection. And adding 6 at the end is going to make it go up 6. So it's going to have to be this one. This one right here is going to be left 6. This is up 6. Notice the difference. This is in the exponent. This is outside at the end. And we can graph that to make sure we got it. So if I did 5 to the x power, and if I did negative 4, 5 to the x plus 6, you notice that it's flipped, so it's reflected. You notice that it's skinnier. Maybe you can't, but if I put a 4 out front here, oops, that kind of made it a little bit skinnier. See the difference there? So the 4 will stretch it, and then the 6 did shift it up. So if that were not there, it would be right level there, but the plus 6 did make it go up. So it's going to be that one.